Hey everybody, I hope you and yours are healthy and doing well. In my way of thinking, this is week 2 of the Apocalypse Lectures. Not that it matters, but in any case, what we've done sort of conceptually is gotten our cargo from here to here, and we are here in the overall state of affairs. That could have been through this particular trafficking pathway, which would be the COP2 intergrade pathway. I didn't mention it, but it could also be this way into Urgic and then into the Golgi, either through here or maybe by fusing Urgic with the Golgi directly. Some people think that happens. But in any case, all of that would be intergrade and COP2 mediated. So now the process of continuing with the cargo, we're going to go through really quickly. So the Golgi I'll talk about for like 30 seconds. Sorry, Golgi, but that would put us out here in the trans-Golgi network. Say if we were making something like collagen, which I've been talking about, something that is part of the extracellular matrix, then it would go through a pretty standard, although not particularly well understood, trafficking pathway called exocytosis, and that would put it out here. Keep in mind that that would also apply to something like GLUT2 or CFTR, integral memory proteins that would be considered cargo for exocytosis, even though they're not actually being secreted. There's another aspect to exocytosis that I'm going to talk about. We'll maybe spend a minute altogether on it, and then talk a little bit more about endocytosis. But before doing that, I wanted to talk about retrograde trafficking, which is the process that is COP1 mediated, and it goes from Golgi or Urgic, which I'm pretty sure your book calls vesicular tubular cluster. I don't know what else that would be. There's the dogs. Back to the ER. So that process is called retrograde. It's also called the retrieval pathway for very good reasons, because that's exactly what's accomplished. Figure 1325 in your text covers that. Cargo now is yellow, because why not? Haven't used yellow yet. So that would be our collagen, for example. But in the case of retrieval, what we're talking about is something that would have this color right here for reasons that'll be clear by the time we're done. But this would be something like BIP in the ER lumen, something that we describe as an ER luminal protein. So what does that mean mechanistically? Because what we're thinking in terms of so far is the overall flow of polypeptides concentrated first as a result of co-translational translocation in the ER and sort of diffusing, although it's not really, outward towards the plasma membrane. So if that's going on, then how can you even talk about having an ER resident protein? And the reason is because of the COP1 pathway. So what happens is, and the distinction between yellow and red, funny looking diagram here, is the presence of a particular sequence that is 4 amino acids long, KDEL, lysine, aspartate, glutamate, and leucine, that provide the information needed to make sure that BIP and things like it, the chaperones, for example, in here, are there in abundance in the steady state. So in the COP2 pathway going out, so if things work according to plan, the soluble cargo and integral memory cargoes go out the way we talked about, and that vesicle fuses with the Urgic or the Golgi, and everything is fine. But during that process, it's very common for something like BIP, that's supposed to be in here, to sneak out into those COP2 vesicles, in which case, of course, it will be here and here. And if that's allowed to proceed, which it isn't, but if it's allowed to proceed, then you end up with, for sure, a very wasteful process of putting something that is totally not needed, either here or outside the cell. It could also possibly cause some pathological consequences that you want to avoid. So the way that's avoided is a system that is designed to recognize things that have escaped and package them back to the ER in these COP1 coded vesicles, and that involves recognition of that KDEL sequence, that 4 amino acid long sequence, by an integral membrane protein whose job it is to fetch it out of the Golgi or ergic and package it, help it get packaged into the Cop1 vesicles. So that protein in green is the so-called K-del receptor, and what's shown here is the specific interaction between the receptor and that 4 amino acid long sequence. The rest of this symbol is whatever protein it is, BIP or whatever. So that triggers a recognition event that leads to the budding off of a Cop1 coded vesicle, its uncoding, trafficking back to the ER and fusion using the exact same mechanisms that we talked about. But I did want to spend a little bit of time about the specifics of the signaling that involves going from here to here, really going from here to here to here, because that's interesting for other reasons.